Hello, testing, 1, 2, 3. Testing, testing. It's a good thing I tested the audio because I didn't have the microphone connected somehow. Not sure. But I thought I would just turn on the camera while I was working on this mess of a drawing that I have. This house has taken on a life of its own already. And I'll just put the roof back over here. It's funny because I don't need, when I'm building a house for somebody and I'm drawing it too, I don't really need a lot of fancy drawings. I just need to transfer, I need to relay the design concept to the owner, right? I don't need a lot of construction documents because I can build this house off the back of a napkin. Okay, so what happens to me is I end up getting a lot of garbage, honestly, in the drawings, and it's okay. Delete guides, as long as I can communicate with the owner what's going on. So what I was actually working on was we've got this, and oh, that's a window. See, this is what I'm talking about. Make a group. That goes in. We were talking about I was talking with the owner about windows the other evening in a meeting, in an online meeting, and I drew a rectangle there, and it's in the wrong layer. But where we stand on this house to try to get around to the point, I guess, and there is no point to this really. It's just a live work session. So any information that you gain from this is like coincidence, not unintentional, because I'm just trying to do some work and I'm trying to share as I go along. But let me show you this video, and it might catch you up to where we are exactly. And let me check to make sure the desktop audio, is running. Barrett and I are here checking our footings to see how our layout's going to work. And our house might grow 6 inches. I may have to move this wall over a little bit just to keep it. It's funny though, Barrett, I was just telling Barrett, no matter how wide we dig our footings, these are 3 feet wide. You always have to kind of maneuver the house around a little bit sometimes when you're staking it. I'll have my surveyor come and pin the footings, and that's why I'm here checking it out before he comes. It's looking good though, isn't it, Barry? Mm-hmm. The scale of this thing is bigger than, look, there's the truck. But and if you were standing over there, you'd be like that tall. So these walls are they're 13 and a half feet tall. So they have to be like 12 inches thick. And then I got a brick ledge on the inside for the floor to sit on. And I think I'll do a little video on that here in just a minute. So that was that. And I was standing right here on the footing, which is down in there. You can see down in there. So right now the issue is, I've kind of figured it out, but the issue up to this point was whether we do a crawl space, right, like this, or we fill all this in with gravel and do a slab. And to me, it was kind of obvious that with the cost of gravel right now, filling all this in with gravel is going to be a huge cost. I didn't actually do, just by experience, I know that this is going to be a lot of gravel. The cost of this gravel is going to be at least equal to this framed floor system. Now, what we gain from this is first of all, a storage area. If I can quit going in there, we'll level out this floor in here. See, this is sloping downhill right now. We'll kind of level this out, and she'll have a storage area. Plus, we'll have a place to put ductwork and a split unit, so the air conditioning, the air handler can go down here. And also, we can put the water heater down here, and we're going to encapsulate this crawl space because there will not be any way to ventilate it per code. Okay, the code requires your foundation vents to be 4 feet from the corner, each corner, and then you have to have one for every 150 square feet of area of your cross. So there's no way to properly vent. You see, you got 3-4 walls here that are underground. Okay, so for me it was a natural choice, right? The owner wasn't so sure, so I had to kind of do this whole thing of going through the cost analysis. The thing is, this whole carport here is going to have to be filled up with gravel anyway, which was a huge cost. Okay, now she bought this lot. I didn't choose it. Okay, and it's pretty steep over here on this end. Over here, it's not too bad on this end here. So let me see if we've got any comments. Anybody? Let me know if the audio's okay. I'm in the tiny shack and I've got air conditioning going because it's 100 degrees outside and 90% humidity. So let's go back. So what I was working on, and this is kind of the live work portion, was that I had put this floor in here. I'm going to move these piers down underneath. Now I'm debating this. They'll go down here and they'll go underneath. Okay, like that. Now what I have to figure out is, based on the height of this, the height of these walls, and see where I'm standing now, the grade comes down, and this wall daylights over here. Okay, like it is here. Like I've got the drawing's pretty accurate. Okay, so the question is how tall to make this first portion. Let's move this floor out of the way for a second. I'll just move it back 50 feet. So what I have is, we're going to pour this. This will end up being a 12-inch thick concrete wall, mainly because of this wall on the front. Okay, it's going to be like 13 feet tall, maybe 14. And that's one thing I got to work out. So right now I've got it at 13 feet, but come up about 3.5 feet, and there will be a brick ledge. And we're calling it a brick ledge because that's what the concrete guys are used to calling it. But it's really just a ledge to put our floor system on, right? Because what I want to do is build this floor system in there. But while I've got the floor system moved, the floor framing moved, you can imagine if you visualize a concrete slab sitting on top of this. I'll just kind of give you a rough idea. And it's 4 inches thick. let's say that's the floor, okay? And you have to bring it up that high because it has to be out of the grade over here a little bit, right? You can't have it down in the under the ground, right? It has to daylight. That's what the term daylight means. So, but what happens is the lot slopes this direction really badly, bad and badly. Okay, it breaks breaking bad this way. So what that does is create this huge cavity right here where the foundation access door is. It's so much that I can get a full size door in here. Okay, now if I took the door out and I filled this all in with gravel, imagine how much gravel that would be. You would have to fill this whole void all the way around. And this thing is, 70 feet, 70 and a half feet by 28 feet. Okay? So that's a lot of truckloads of gravel. And the street is up here. What happened to my road? My road's gone, but it's in there somewhere amongst all these plethora of layers. There's a road. It says road right there. That's bizarre. So it's hiding. But there's a road up here, right? And the only way to get gravel into this basement would have been through literally a conveyor system. Okay, if we go back here, you see the truck, that's the road up there. There's really no real access to get around and down and around and inside this crawl space. This basement. So if this was a slab on grade down here, these pier footings wouldn't be here. And we would pour our foundation wall, and we would come back in and put 4 inches of gravel on top of this whole thing. Okay? But over here it falls off. Okay? And let me go back. Can I go back? So it was a trade-off, right? It was, and honestly, it's triple click, 183, delete. So honestly, the floor framing is going to cost a little bit more, okay? But what you gain from that, I don't even think, so honestly, I say honestly, it's like a, what's the word, euphemism? It's not really honestly, because I don't know. If I knew, I could just say, but the point is, the trade-off is, and what you want to decide on in a case like this is, what's more valuable? Is the crawl space of value to you? Does it add storage? Does it give you a place to put equipment? Right? Does it keep you from having to put plumbing under a slab? If I pour a slab down here, I've got to put my gravel in first. I have to somehow convey the gravel over with a conveyor. Get it in there, get a machine around here, get in there, smooth it all out. Then the plumber comes in and digs out the gravel, digs out trenches in the gravel to put his plumbing in, right? So I avoid all that. I avoid the gravel, I avoid the extra labor from the plumber. Plumbers, they just love that. They love that idea of being able to charge more. They're like the mafia, okay? Plumbers are the mafia in construction. 100, what did I move? 50 feet. So, guess what? ArtisanTony does. I circumvent the mafia, the plumbing mafia. And I say, you know what? You're going to have 3 feet down here. Even your fattest plumber, even I could get under here and put plumbing under and ductwork. Okay? So don't be coming and complaining to me. Vorak. I like the name. That's cool. So anyway, so what I got to do now is I got to tell my concrete. You saw in the video, we got the footings poured, and we're getting ready to pour the walls next week. So guess what? ArtisanTony has to do. ArtisanTony has to spend his whole weekend figuring out how tall this wall needs to be exactly, because they can do that now. We have technology, and you can actually pour a concrete wall to an exact height, and it's awesome. So what I did was I said, okay, I have an X amount of crawl space that I want. Then I have an 11 7/8 LVLs for a beam, and I like to overkill the beam, so I've got 3 of them. I only need 2. I put 3 because when you put 3, you're able to lap it where there is a joint. You're able to lap it properly, and that's another video. But right now I've got 11 7/8 beam, and I've got 2x10s at 16 inches on center. And what this does, it's funny in construction, you gotta weigh all these different options. So the option would be to put floor trusses all the way across here. I could do that. They would be 2 foot deep, and they would be 2 foot deep. They'd be 24 inches tall, and they'd be 2 foot centers. Or they might be on 19.2 inch centers. That would be a factor. But guess how long I have to wait on trusses right now? 4 to 6 weeks. And unfortunately, I can't order trusses until these walls are poured. So there's a little bit of a dilemma in construction right now where, in back in the day, I would be able to pour these walls and get trusses made in like 2 weeks. Now we're talking 4 to 6 weeks if you're lucky. So what I do is I design a system where I can just go and buy 2x10s, right? And so I know what they span. I don't span 2x10s at 16 inches on center any more than 14 feet. Okay. Now this is offset from the center because of the way the walls work out. Where's my floor? And floor. Okay, so most likely I deleted the floor layer, and that's why it's not there. Awesome. That would be number 3. So, alright, cool. Anyway, there's a load-bearing wall that sits above this girder on the first floor, and on the second floor also it works out pretty good. So these are 14 foot 2x10s, and you can see now they're 16 footers. But if I measure the span on a joist is from where it leaves the support member to the beam. So see, that's 14 feet exactly. From here, from there. But you see, to get that at 14 feet, I had to use a 16 foot 2x10. Now, what I'll do is I'll actually cut 14.5 inches off of it, and I'll use that for bridging. So if I come back 14.5, you see, yeah, that's genius work right there now, okay? I'm just kidding. So what that does is it gives me a block, it gives me a joist and a block, and the bridging goes down the middle. I like to use solid bridging. I don't like the modern metal bridging that's X bridging. It's noisy, and anyway, it's not my kind of thing. But what I'm going to do now is I've got all my joist in here, and this is my subfloor. I just kind of started it, and for now I'm just going to make it go. Thank God the air conditioner went off. I should say thank God I have air conditioning, really, instead of complaining about the noise. But I feel like I've been yelling this whole time because the air conditioner is right there. If you don't know, I built this little tiny shack. It's a long story. I keep forgetting how long of a story it is. My wife decided that she didn't want to be married to me anymore, and there was a lot of factors there. And why am I getting into this? I have no idea. But I ended up having to build this. I ended up bought this property in the woods where I wanted to live anyway. For my life's goal was to be out in the woods, and it turns out my wife didn't like that very much. My ex-wife, so she left me. Look at that. And I bought my property, my dream property, and I built a tiny house on it. So now, whatever. I can roll with the punches. It's not a big deal. Life goes on, and it's up to you, to make it happy. Nobody's gonna make it happy for you. You gotta make it happy for yourself, and just go for it, man. Just don't let a woman. Message to all men: don't let women control your life. Okay? I know that's cruel and unusual punishment, but if you've been married like I have twice and had women kind of promise you they would be your wife forever, like I have, and I'm having a push-pull time here, and then they change their mind. Now I'm not like Tom Selleck or anything. I'm not that good looking, but they knew that when they met me. I haven't changed. I've always been a chubby boy, and I think what it is, they don't like my Renaissance attitude. Anyway, I'm just trying to be funny on a Friday. And I like to make myself chuckle, which I often do. So here I go. I got my joist at 16 inches on center. And I got my 3/4 inch Advantech, which is superior to all other floor coverings, or subfloor. Should be 3/4. It is superior to all other. Okay, I'm going to say other forever. Other subfloor. So, one thing I thought it would be kind of cool is if I had my floor plan, which is actually, I'm flabbergasted that I don't have a floor layer, and somehow it got deleted. So I'll just have to make do here, and I was going to show you how I plan on figuring out this wall height, and it's going to be easy. And I think I'm just going to draw a section or a little part of a wall. So against a concrete wall in a basement, what we normally do is we'll start out with a 2x4, a bottom plate. Let's go all the way to the end. It's Friday. Let's just go all the way there. And it would be 3.5, and we'll just go 12 feet. Okay. What we do is I allow 1.5. I allow for a full thickness of a wall against the concrete. Okay. What that does is it gives me a full thickness of a wall to put plumbing in and receptacles and all that. I don't have to worry about, furring. Some people would want to fur this wall out. Let's see if we have any comments. I got here a little late. Is that triple beam made of 2x10? You can do it out of like triple 2x10s or 2x12s. Funny enough, I always overkill my girders, and just because it really doesn't cost that much, maybe $200 or $300 more. And what are you getting? You're getting a superstructure, right? Who's going to save $100 and have a bouncy girder? But I love I like LVLs. So that's literally a 3-ply, 1 3/4 by 11 7/8 LVL. Okay, there's not going to be anybody come and put any weight on my girders and that makes them deflect. So was there another question? Hey bro, hey Funky Prepper. I don't think I've talked to you in a long time. So what I'm doing now is I'm trying to figure out how tall this wall's going to be, and just for the fun of it, I'm going to draw myself. What I would like to have is a 9-foot ceiling, and why is that not snapping? That's bizarre. Here we go. Let's just draw ourselves a 3.5 by 1.5 rectangle, and that's going to be our stud. That's going to tell me how tall. We're working on how tall the wall is going to be. Now, an 8-foot wall stud is 92 5/8, and a 9-foot stud wall, a 9-foot stud for a 9-foot wall is 104 5/8. 104 5/8. And after 40 years, you just learn all these little rules of thumb, right? That's the fun part of getting old. And I'm gonna, just for the fun of it, I'm gonna move this over 3/4. It's that you learn, you end up learning a lot of stuff over the years. But so what she wants is a 9-foot ceiling, and what you find is that the stud length is designed to give you like for a 9-foot wall, the overall wall height will be 9'1" 1/8, and I'll show you. Okay, and that gives you room for a floor covering and a ceiling covering, and still have close to a 9-foot ceiling. So what you'll have is, we'll just go here and put some studs in here. We'll pretend like we're going to put like 10 studs. 16 times 10. Okay. So I got lucky. That was pretty close, wasn't it? We'll just go ahead and move that one out. I'm losing my mind here. Why is that not? I'm trying to select that stud and I can't select it. There we go. And of course, we wouldn't put it there. We would back it off a 1/2 inch. This whole wall would be back. We would leave a 1/2 inch airspace between the concrete and the framed wall. What that does is it allows us to not have to use pressure treated lumber, because pressure treated lumber is more unstable than your typical framing lumber. Now what you're going to have is a double top plate, and we're just going to put it back here because we would lap it at least couple of, I'm just going to put it right here for right now, but we would lap it. The whole purpose of the double top plate is to tie your walls together, so it wouldn't end right there where that 12-footer ended. And so I'm going to pull it back here, and then this way it would be pulled back 3.5, so that the other wall coming this way, top plate, could overlap this wall and tie this wall going this way. Can I show that? How hard would it be? I got all afternoon, so I might as well show 90. Oops. And then this wall would go right here, and then you'd have a corner like that, and then this plate right here would lap over like that. So that's the whole purpose of top plate, double top plates, is it ties the walls together. This top plate lapping over this wall, nails down through there, that ties that together. And this next wall that's going to be or next section of this wall, its top plate will be lapped like that, see? And that ties this other section of the wall into this part of the wall. And normally we'd go back, you know, 2 studs or so. We'd go back at least, you know, 32, 48 inches. But what I'm trying to do now is just see how tall this wall needs to be. And you can see I've got it pretty close. So what we'll do is, the reason I'm doing this is because I want to be able to use standard length studs. You know, these 104 and 5/8 studs, you can just go to your building supplier and buy them, you know. That way we don't have to cut all the studs. And if we do this right, you know, my framer, Paco, will be really happy. Any other comments? So if I get this wall at the right height, you can see I was close. And now one thing I got to keep in mind here too is there will be a plate on top of this concrete wall. I got to get it up out of there. And it will be another 2 inches wider. So really this wall what I did was I made this concrete wall 10 feet. How far am I off? I'm off 13/16. Now that's not a tragedy. But you can see what I did. What I did was, if I move this back 10 feet, you see what I did? I have a crawl space height of 3 feet, and then I put 10 feet of wall on top of that. And I was starting out with standard form, you know, standard concrete wall heights for basements are 10 feet. So I thought, well, I'll put a 3-foot crawl space, and then I'll just run 10 feet up. The other thing is, the road, the street is out here on this elevation right here. So this puts this little retaining wall over here. This part right here is a retaining wall. That puts it level with the road. And so there's a lot going on here, you see. All this grade is based on points that I had my surveyor give me. All this grade in here. And you can see, if you go back to the video, it's pretty close. It's hard to see from this angle, but you can see that how that slopes down. Well, the top of this concrete wall, which again fools you because, believe it or not, it's 13 feet from here, from this footing up to. I have a picture the other day of guys standing over here, and they're only about this tall. It's misleading. So the wall is going to be up here and pretty much flush or level with the road. The road slopes down this way, down. So, you know, it's kind of a lot to think about here. Oh, good, the air conditioner went off. I feel like I'm having to yell over it. But, so, what I really want to do is I don't want to really tell my concrete guy, you know, you got to go, 13 feet and 3/8 of an inch. What I want to do is tell him he can go 13.1. So what I might do is see what that would do if I raise this up 1 inch. Or I'm going in the wrong direction, aren't I? I need to lower it 1 inch. So if I brought this down 1, and I've got all these groups and I'm trying to go in and out of them. And then let me just bring this over to the corner where it's easier to snap. There. That's our treated, that's a pressure treated plate that's sitting on top, because the joist will come, the floor joist will come and do this. They will stand up first of all, and then they will turn around 90, and then they will be, let's see, let's undo that, because first of all what we would have is a box seal out here, and these are going to be 9 1/4 also. What is this now? 5 1/2. So 2 what are we going? 3 3/4. What is that? I can't. It's Friday. I can't think. What is that? 9 1/4. I got lucky. Quick math. Right. So then you would have this, a joist. If I can get it to cooperate. 90. So you see, we're really not that far off. And what I, like I said, I try to keep I really don't want to tell my concrete guy, make it, I can try. Like I can say, can you make it 9 foot 11 or 9 foot 10 3/4? I can tell him 9 foot 11 and he won't laugh at me. But if I tell him, what is this? It needs to go back up this much. If I tell him 9 foot 11 3/16, then he will laugh at me. Okay, so you kind of have to choose your battles here. But I don't want to have to notch these out. I'd rather this point right here. Like what I'd rather do is raise all this up a 1/2 inch. And I think I just solved this. And then have him make the wall 9 foot 11 1/2. I can probably buy lunch, buy his lunch and get him to do that, because concrete guys are picky and they're fussy, like old women. And sorry, old women, but you are fussy. And so that's going to that'll raise this up a little bit. Like that. But honestly, what's the problem here? The only problem we're going to have is when, this is the kind of stuff you got to work out. Right? So you have to kind of just 5/16. The problem is when I come over here and I have a wall that's here and all these joists that are coming out are bearing on it, and then I have this wall that's out here. Where's my red? There's my red axis. That'll be That'll be back a 1/2 inch. There we go. So then what you'll have is joist. Let's get rid of this. So you can see this will be a box seal, a header joist, whatever you want to call it. We got like 20 names. Rim joist in construction. We have all kinds of, depending on what part of the country you're from, you know. And there, let's see. So see if you see, but here this demonstrates the problem. If I build this wall and then I just set this down on here, then this part of the floor is going to be lower. What was that? It was 5/16, right? And you know, nobody would really ever notice that. But since I made a video and I'm showing it, then now I got to worry about it. The owner's going to be like, "Oh yeah, I'm going to be watching for that." But so this joist, and I'm not going to draw all this because it's going to take me, you know, a whole day. But if this is 14 feet long, and actually I think they're going to have to be 16 footers because of the way the closets work out, but they're not going to be bearing that far. There's a difference in how long the joist is and how much it bears. How much it spans. So just because a joist is 16 feet long doesn't mean it's spanning 16 feet. It's only spanning, you see now it just occurred to me, we could shim up the see, by planning all this out, you come up with ideas, right? We could those will lap like that. We could literally just fur up this band out here, just shim it up, and when the subfloor comes out, right? So that might be a good option. I don't know where this came from. Oh, I think that was an extra. These are extra, and so that means these are extra up here. Let's see if we got any comments. I can tell you who else is fussy and picky. Oh yeah, really? Yeah, Night Strike. Are you looking at the man in the mirror? Are you Michael Jackson? I need to talk to you, Michael Jackson, about my. I don't know if you saw my video where I donated the printer, the resin printer, to the STEM school. But I did, and now I'm going to research. I think I'm going to get the printer that you have, but I'm going to get a better one, so mine will be better than yours. I'm just kidding. So what is it? An Ender 3? Is that what you have, Mike? So I'm just kind of roughing this out because what I'm trying to do is think about all the issues I'm going to run into with the height of this concrete wall. Because I got to tell him on Monday how tall to pour this wall. You see, the first thing he's going to do is say, "Hey Tony, from the footing, how tall do you want this wall?" And you see how we always dig the footings down a few inches below the grade right here, so that the earth can act as a form. So I actually need to add the height. That's probably another 4 inches. So I'll have to add that to the height of the wall, because what I want is 3 foot clear. I want 3 foot from this crawl space. Floor is really good. He got this on grade. This is an excellent pad here. It's almost perfectly level for the crawl space. And I know if I go up 3 feet from any point in here, I'm going to be good. But I got to go up more than 3 feet because you can see it's down. The footing's down a little bit. Okay, so I'll go up. Let's go back here. I'll go up because that's one thing I'm not showing here. I'm just showing the ground as if it was backfilled. I'll probably have him go 3'4" or 3'6" instead of 3 feet, because part of this wall you're not seeing. It's below the dirt down to the footing. And then what have we got here? We've got 9'11.5". What I may do is try to figure out how is just to let him go 10 feet so I don't have to listen to him complain, honestly. So that means the only thing is I would have to I'm going to ask him whether he would. So you can't make everybody happy in construction, so you try to take your biggest whiner and you try to make them happy. Okay, in this case the concrete guy is the biggest whiner. Paco, my framer, is honestly, I've known him for 20 years. We're like brothers, and he's been framing for me for that long, and we love each other, and we're like brothers. And he's not a whiner. He's not a complainer like the concrete guys are. If I tell them to make this 9'11.5" from that 3 feet, they're going to complain, because and honestly, I would too. Their forms come in like you might have an 8 foot, a 2 foot, a 1 foot. So what they try to do is form it up so that they can pour the concrete to the top of the form, and then just check it periodically with a laser. They don't want to have to form this wall up taller than this and pour the concrete down inside of it, because it's harder to trowel when they're trying to finish the top. Oh, do you need me to put it together for you? I think I'm going to try. Can't I buy it? I can buy it assembled, I think, right? And I was thinking about getting the Ender 6. Does the Ender 6 have a bigger bed? Because mine has to be bigger than yours. That's the first requirement, is I have to be able to print something a lot bigger than you. Okay, that's but you can see my dilemma, and this is what I'm working on this weekend. I'm going to get the floor plan all fixed up. I do have a floor plan. I have a version. Let's see if I can open it. And again, this is one of the issues I run into, is that I don't have as high of a standard for myself when I'm doing drawings for me to build something as I do for other, for my customers. If I just do some elevations and they're happy, I'm not going to spend time doing a lot of construction type drawings, because I already know how to build things. So let's go in here, and I don't know what happened. Somehow my floor layer got deleted, but you can see the mess I'm dealing with here. If I go to first floor plan, so I'm dealing with a mess. This is a total mess here. But this is it right here. I'm going to try to copy it. And I'm going to try to go into the other one, and hopefully it's going to be in the right spot. And it wasn't. Where did it go? Something is wrong. Something is wrong. I may have to stop this live stream because something is wrong. This drawing is all screwed up. 1, 2, 3. I'm missing 3. My floor folder, and you saw me just paste that in place. Paste in place. And it's nowhere to be found. So let's go back. Where's my work thing here? Yeah, I got this set up. So I'll have to deal with that. But I was thinking it might be hidden somewhere. But anyway, I just thought I would share this process, rather complicated process of, first of all, deciding whether you're going to do a slab or a crawl space in a basement. So if this grade had been consistent, a consistent slope, the same, if the slope had been the same over here, if the slope had been the same over here as over here, then that flat area could have been maintained all the way across, and a concrete slab would have made sense. Okay, but since this corner of the property dropped off another 8 to 10 feet from here to here, you can see, then it made sense to do a crawl space, because otherwise you'd have to fill all this in with gravel. You can't what would be the term? There's a myth that you can necessarily span a concrete slab this far, and you certainly can't span it this far with a metal pan. The cost of that becomes prohibitive, and you could just most likely fill this up with gravel before, and we much rather would have gravel under the number 57 gravel under the slab, just because as a builder I don't want to have to worry about it. And let's see, this goes back, what did I move that, 10 feet? So let's see what Mike has to say. It needs to be bigger, says the guy who got rid of the resin printer. Yeah, but I'm not going to have a curing station and a wash station to cure the resin either. Ender 5 is the largest. The Ender 6 has the panels and doors, but not as wide. Well, I like the panels and the doors, because like my Anycubic, since it had the enclosure, I was able to drill a hole in the top of it and vent it outside, and I still have that vent hanging out of the wall, so I'm going to reuse it. Ender 6 print bed is 250, 250, 400, 350, 350. So I could get some plexiglass and make my own enclosure then. So, but see, this is why I ask you, because I'm going to do more research this time. Last time I bought the Anycubic Photon M3 Max on a whim, just because it looked cool. So this time there's going to be some research. But yeah, probably get the Ender 5 and then make my own, fiberglass or plexiglass enclosure that I can drill a hole in the top and still use my vent. Because see, I'm in a tiny shack. I don't know if you can see. What can you see? What can you see behind me? My tiny shack that I'm living in right now is only 12 feet wide by 24 feet long, and I'm doing that because I have 4 acres here that I'm going to build a cabin on, but for now I have to put up with stinky, if after I vented my last 3D printer, it was fine. but until I vented it, the space was so small that I could smell the resin. And I remember being able to, there was a vapor for the filament printers, but I should be able to vent that too. But the resin is nasty. I mean, the resin is it's like an amoeba, you know. It's like, so the only place I had to clean it out was in my kitchen sink, right? It's a 25 by 25 sink, and I would put the vat in there, and it's not water soluble, so now you gotta use alcohol or something to clean it, and the resin just like gets all over everything, and then it gets all over you, it just it's like a monster. It's like a slippery, slimy monster. And so, anyway, I think I know how tall to make this wall now. And what I'm going to have to do is go find my floor plan. This is a mystery, honestly. I don't know why. You saw me go to that other drawing. I'll say yes. I think this has to do with the this drawing was even more of a mess. And I went to first floor plan. This drawing was really a big mess. Let me see what layer that's in. 2D plan basement. Yeah, that's what it's supposed to be in. I'm going to copy it. I'm going to go back to the current floor plan. The current point. Now, if I turn this on first floor plan, that's the second floor plan. And then I put this back on perspective. And I say paste in place. Oh, look, it pasted there, and for some reason it's turned off. So what I need to do is go expand everything, and turn let's try not to do that. Let's go turn everything else on. And I have no idea why this is in red, okay? So I have corrupted this drawing so badly through bad drawing practices. I have no idea why it has all those funky colors in there. And that's just bizarre. It literally is bizarre. Oh, I know what to do. Style. It should be on construction documents. Yeah, there we go. Now if I turn this on first floor plan, you see what's happening is you saw. Anyway, this is the second floor plan, and for some reason the first floor plan is in a. Let's go back here. So anyway, I'm not going to bore everybody with that. That just goes to show you that honestly, what's really important in CAD work is keeping all your layers organized, keeping all of your work in those layers. Like here, you can see this is I picked the foundation scheme. Okay. I think I've got groups. I got nested groups, and I'm pretty sure the floor plan is nested in some group that's turned off. So I'm gonna have to go figure that out. But the thing I just kind of wanted to share in this video was if you're building a house and you need to plan out this point where you tell your foundation guy where how tall to build this wall. And also, if it's over 10 feet, really if it's over 8 feet, you should get some help with engineering. You can see these footings are 3 feet wide, okay? The reason they're 3 feet wide is because this wall is going to be at least 13 feet tall. So, as a rule of thumb, that 3 feet would be good up to 14 feet tall. But the thing is, your wall is going to set back here. You're going to have 2 feet of that exposed to the outside, and the wall is going to actually sit towards the back third or so of this footing. It's not going to sit in the middle. And the purpose of that is that on these tall walls, they want the grade, they want all the backfill, and they want this footing to act as a, sort of in a structural sense to keep the wall from pushing. If it wants to lean back, it's going to have to pull the footing out of the ground with it, like that. Okay, that's not the technical answer, but that's a practical answer. And so, you really need help if you're building, concrete poured walls this tall. Like I have a guy locally that his name's Greg Arnold, and he, for $450, he'll do. If I do the drawings, he will, he'll look at it and verify it and stamp it. After you get that part, then you're going to pour your footings, and then your concrete poured walls guy is going to come and say, okay, well, how tall do you want it? And this is what this is all about. What I did was I had this standard of the road. The road is out here, and I wanted the driveway to be not, it doesn't have to be perfectly level with the road, relatively close. So we had to shoot grades from the road here all the way down here at this corner, and also this corner right here. And then I decided that how deep of a hole. I told my guy to go 8 feet from here. This is the original grade. You can't see it because he's got topsoil stacked up here. But the original grade is right in here somewhere. Well, you can see it right there, that dirt line. And so it's 8 feet deep from here to here. But I gave him that 8 feet. I gave him that dimension. So you'll have to give him the dimension of how far to sink this into the ground, right? And then from there you'll have to tell him how tall to pour the walls. So there's a lot to these basement homes. It's not like a crawl space where it doesn't really matter that much. And this is the unique thing about this house is that it has the aspects or the attributes of a basement and a crawl space. It's odd. I don't think I've ever done one exactly like this where I have a crawl space down here instead of a slab like this, and I actually am doing it to kind of experiment a little bit. I don't think the owner's going to be watching this. I'm not really experimenting. I think this is actually the best way to do it because you're going to have a space for all your mechanical work can go down here. The water heater. You're going to have storage down there. Will encapsulate the crawl space. You can have a place to put plumbing very easily in there without having to do it under a slab. Just all kinds of. So if it was my house and I'm doing this, and even if it cost a few $1,000s more to have the floor system instead of the slab, I would do it. Anyways, give me a call. Yeah, I will. I'm gonna pay you a consulting fee. Mike is a good guy. I've known him for a long time, and he helps me with my website stuff, the back end sort of stuff that I can do the content management stuff, but he's the networking guy and all that. So he's a good guy, and I rent a server from him too. If you have any needs for that, he also rents servers that you can put your website on or whatever, your blog or whatever. Alright, well, I think I'm going to stop here because now I know basically how tall this wall needs to be, and I was only, I don't know, a half inch off from what I thought it was going to be. So I'm happy with that because I've already showed the owner one time how far this was going to be out of the ground over here, and I didn't really want to change it. And also, I had already told the guy digging the basement how deep to go from here, that point. So I'm happy with all this. And by making this wall this tall, we'll keep the carport relatively, you know, not level, but some kind of relationship with the street out here. You know, you don't want to pull off the street and gonna go take a dive into your house, your garage. We especially don't want rainwater, you know, coming and taking a dive into the garage. So, well, thanks for watching. If you made it this far, and I do these pretty often, and but thanks for watching, and we will see you on the next one.